Particle physics and the accelerator assignment. In this assignment, you have the structure questions related to the topic. So we'll start with question 14. In question 14, between 1909 and 1911, Rutherford's alpha particle scattering experiments provided evidence for the nuclear model of of the atom. Alpha particles were fired at a thin gold foil and their paths were observed. Describe the observation from the alpha particle scattering experiment. So if you recall this scattering experiment, what Rutherford did in a vacuum, he targeted the metal foil, the gold foil with the fast moving alpha particles. And he observed what he observed. He observed most of the alpha particles were able to pass through. We just have to write the observation. Most of the alpha particles, not the conclusion, just the observation, because the question is describe the observation of the alpha particle scattering experiment. So he observed most of the alpha particles were able to pass through. Few of them deflected and few of them bounced back. But we have to write in words according to the question. So what will be the first point? We'll mention most of the alpha particles pass through straight through the gold foil, and were undeflectedly most of the alpha particles move. Few of the alpha particles were deflected or deviated at an angle less than 90, and very few of them bounce back or return back at an angle which is greater than 90. That we have to write here. But because the question is observation, conclusion, you don't have to write here that most mass is present at the center or nucleus contain mass. You don't have to write that point. Or major portion of atom is empty. The next is an alpha particle approaches a gold nucleus. It reaches a distance of 4.5 exponent minus 14 meter from the gold nucleus. Calculate the force between the alpha particle and the gold nucleus. So you have to use here the Coulomb's law. The proton number of the gold is given 79. So it has 79 protons. And the alpha particle, it approaches the closest distance, alpha particle, 2 proton, 2 neutron. And the closest distance of approach is given 4.5 into 10 to the power minus 14 meter. So according to Coulomb's law, if we want the force of attraction or repulsion between the two charges, that is directly proportional to the product of the charge and inversely proportional to square of the distance between them. So we have, like example, force F is there between the electrostatic force between the charges. It's equals to K Q1 Q2 over R square, where K is 9 exponent 9, the constant, a fixed value. Q1 is the first charge. You can take any one of them as first. So if I'm taking alpha particle as first, so it will be 2 multiplied by, because neutrons are not having a net charge, proton is positive, which is 1.6 magnitude into 10 to the power minus 19. So that's the total charge of alpha multiplied by the total charge of the gold nuclei, which is 79 times 1.6 into 10 to the power minus 19, and divided by the distance between them. So they mentioned the distance between them is 4.5 into 10 to the power minus 14 and then square. We just have to substitute the value. The value of the K, yes, it will be there in exam and you can memorize. It's a permittivity of a K is 1 upon 4 pi epsilon. So whenever you have a vacuum between the particles or air, it is about the same value. So 9 exponent 9 or 8.99 exponent 9, that's fine. So the value of F will be 17.96 Newton. That's the force between the alpha particle and the gold nuclei. Question 15. The equation for a beta positive decay, as you can see, a proton changes into a neutron, a positron, and electron neutrino. Why there is an electron neutrino? Because if there was no electron neutrino, then the lepton number will not be conserved. Use the information in the table, describe how a proton changes to neutron. So, how a proton has turned into a neutron. We know the composition of the proton. What is the composition of a proton? Proton is up, up, and down. So proton is what? Proton is up, up, and down. Neutron is what? When the composition, the quark composition, it's up, down, down. So what actually happen is if D cancel with D, like D same both side, and U cancel with U. So actually when a proton turn into a neutron, it's the up quark which is turned into a down quark. So as a proton is up, up, down, and neutron is up, down, down. So both side D and U are common. We cancel out. So actually what happened? One of the up quark has been turned into a down quark. That's why it is changing the baryon. Like first it was a proton, but now it is a neutron. So that is what you have to refer here. How the proton changes to neutron? It's actually the quark composition changes. One of the up quark has turned into a down quark. With reference to the charge of the particle, show that this decay is possible. So now we have to check the conservation of the charge. If we want to check the conservation of the charge, the proton is positive, neutron is neutral, positron is the same charge as electron or proton, but positive in nature, and electron neutrino does not have a charge. So we have the same charge before and after. It means that the charge is conserved. The kinetic energy of a positron is 1.58 mega electron volt. It annihilation means when the particle mix with another antiparticle, we call that as annihilation, like matter turn into energy. And a pair production opposite will happen, the energy create the particle and antiparticle. So kinetic energy of the positron is 1.58 mega electron volt. It annihilates with a stationary electron and two photons of equal energy are emitted. Calculate the wavelength of the emitted photon. Mass of the stationary electron is 0.511 mega electron volt per c square, and mass of a stationary positron is 0.511 mega electron volt per c square. So what actually happened? We have a positron. And remember, as I mentioned, mass in mega electron volt per c square is the energy in mega electron volt. So it means if this mass, why this is a very important unit. Instead of kilogram, like example, if I write something is 5 kg, it's hard to understand that how much energy it will give off. But using this mass in mega electron volt per c square, it's easy to understand that if a mass is 0.511 mega electron volt per c square, so it will emit out the same amount of energy. So a positron is there which is having a rest mass. The mass is 0.51 mega electron volt. There's an electron. The rest mass is 0.511 mega electron volt per c square. But this was stationary. This was not moving, but the positron was moving with a speed of 1.58 mega electron volt per mega electron volt because it's the energy. Now, when they annihilate, the two particles combine, it releases photon. But when it releases photon, we have to calculate the energy of the photon. First, we should know what will the total energy released. So how we'll know what will be the total energy released? It will be the total energy because it is producing energy. So if you want to know how much energy is released or energy of this photon release, so the kinetic energy of the positron, the rest mass of a positron, the rest mass of the electron, when we add all of them, we'll know how much total energy will be released in mega electron volt. So this was 1.58. So this is 1.58 plus 0.511 plus 0.511. When we add them, because as I mentioned, this will produce the same amount of energy. So when we add them, we'll know what is the total energy release. So when we work out, the total energy will release will be 2.602 mega electron volt. That's the total energy release. But if we need the energy in the question, we need the wavelength of the emitted photon. So we need the formula E is equals to hc over lambda, or E is equals to hf, first find frequency and then wavelength. But this is what we want to use. We want to determine the wavelength. But this formula, the energy should be in joules. So once we get 2.602 mega electron volt, we have to convert into joules. First, mega electron volt, I want to convert into electron volt. So what I will do, I'll multiply by 10 power 6, like because mega is a prefix of 10 power 6, so it will be 2.602 into 10 power 6 electron volt. Then 1 electron volt is 1.6 exponent minus 19. So we'll multiply by 1.6 exponent minus 19. Now, what about shouldn't we divide it by 2 or no? In this case, why we are not dividing by 2? Why we are not dividing by 2? Because look, the momentum should be conserved. If there was a particle and antiparticle was there and both were moving, like there was a proton, antiproton or positron, I mean, and electron were there, if both were moving, then it should, because the total momentum before is zero, so total momentum after should also be zero. So when they produce a photon, they should produce two photons in that case, so that the total momentum before should be equals to total momentum after. But in this case, a positron is colliding with a stationary electron. A positron is there which is colliding with a stationary electron. So as a result, what will happen? The total momentum is not zero. So when they annihilate, they produce a photon. They can produce a single photon, which will also have a momentum in this direction. So in this case, it won't produce the two photons. It will produce only one photon, a single photon. Yeah, they mention, look, annihilate, and in this case, if it is producing a with the equal energy, then we will divide by 2 in that case. I did not read that part. If two photons are there, equal energies are emitted, then simply the last value, first we are converting it to joules. Because if the last value I'll simply divide it by 2, I'll get the same result. So 2.06 exponent 6 divided, multiplied by 1.6 exponent minus 19, that will get the answer in joules. That is the total energy it will produce. What's the answer here? The total energy. So it will be 4.16 into 10 to the power minus 13. But remember one thing, it's not like always two photon. If in this case, it can produce one photon as well, as the momentum will be conserved, even one photon is there. But in the question, they already mentioned two photons. So this is the energy of two photons. We need for one, so we divided by two. So we got 2.08 into 10 to the power minus 13 joules. That's the energy of a photon we got. Now we get the energy of a photon, so we'll use a formula E is equals to hc over lambda. So if I need lambda, it will be Planck's constant multiplied by speed of light divided by energy. So what is the value of the Planck's constant? It will be given in exam. 6.63 into 10 to the power minus 34. That's a Planck's constant. The speed of a light is 3 exponent 8 divided by energy of a photon, which was 2.08 into 10 to the power minus 13. So when we simplify, we'll get the wavelength, which is 9.56 into 10 to the power minus 13 meters. Is it clear, this one? So as I mentioned, two photons are there. That's why we divide it. It's like I work out the total energy and at the last I will divide by 2. But keep in mind energy should be in joules when you're using a formula E is equals to hc over lambda. A linear accelerator, LINIAC, can produce an electron with the energy of 20 giga electron volt. Calculate the de Broglie's wavelength associated with 20 giga electron volt. At these energies, the energy and the momentum of particle are connected by relativistic equation E is equals to Pc. So energy is equals to P times the speed of momentum times the speed of a light. So we have to calculate the wavelength associated. So we have the formula lambda is equals to h over mv or h over p. How we can work out the p here? Because we want to work out the wavelength, but to get the wavelength, we should know p. So p is equals to energy divided by c. But whenever you're substituting the energy, the value, it should always be in joules. You cannot substitute giga electron volt or a mega electron volt. It should always be in joules. So what we can do, we can even modify this equation, like first find the momentum and then substitute here. But to get the momentum, the energy, it's given 20 giga electron volt. So 20 giga electron volt, first we have to convert into electron volt. So it will be 20 into 10 power 9 electron volt. And then electron volt to joules, we have to multiply by 1.6 into 10 power minus 19. So 20 into 10 power multiply by 1.6 into 10 power minus 19. This will give us answer in joules. What's the value for the energy? This value? What is the energy? 20 exponent 9. So 20 times 1.6 you can do.
3.2 by 10 power negative 9.
3.2 exponent minus 9. Okay. So this is the energy. We got the energy. Then energy divided by speed of a light will get the momentum. So this will be 3.2 into 10 power minus 9 divided by the speed of a light, which is 3 exponent 8. We'll get the momentum. We are using this equation. What's the answer?
1.1 by 10 power negative 17.
So that is the momentum, kilogram meter per meter second inverse. And now we have the momentum. We just substitute the value. So lambda is equals to the Planck's constant 6.63 into 10 to the power minus 34. You don't have to memorize a constant value. It will be given. But when you get used to like using the same value again and again, you will remember these constants. So when we simplify,
6.2 by 10 power negative 17.
so 6.2 exponent minus 17 is a meter is a wavelength associated with this electron. Can they ask to derive an equation E is equals to PC? Yes, they can ask you and you can derive that. How you can derive E is equals to PC? We have the formula E is equals to MC square. Okay. I can write like this E is equals to MC multiplied by C because C square is C into C. What is MC? MC mass into speed, it's a momentum. So E is equals to PC. So whenever particle move relative to speed of a light, its momentum and energy is related by E is equals to PC.